American Rheinmetall Readies Lynx XM30 Infantry Fighting Vehicle for U.S. Army Fall 2026 tests. American Rheinmetall is completing its first Lynx XM30 prototypes for delivery to U.S. Army soldiers, moving the Bradley replacement candidate from digital engineering into physical testing. The handoff will expose the infantry fighting vehicle's two-soldier crew concept, 50mm cannon, protection systems, and maintainability to operational scrutiny ahead of more demanding field exercises. Soldiers are expected to begin familiarization and evaluation activities in fall 2026, examining crew workload, visibility, dismount procedures, maintenance access, and the vehicle's ability to operate with armored formations. The Army plans to place competing XM30 prototypes with the 1st Cavalry Division before a National Training Center rotation scheduled for spring 2027. American Rheinmetall's design combines an uncrewed, use-designed 50mm turret with a two-soldier crew, space for 6 infantry personnel, integrated protection systems, and a modular open systems architecture intended to accept new sensors, software, electronic warfare equipment, and counter-drone capabilities. The XM30 is being developed to replace the M2 Bradley within U.S. Army mechanized brigades. Although it draws on Rheinmetall's wider Lynx tracked vehicle family, including the KF-41 infantry fighting vehicle, the American configuration is being developed specifically around U.S. Army requirements rather than offered as a direct off-the-shelf KF-41 variant. It is designed for a two-soldier crew and 6 dismounted infantry personnel within an architecture intended for connected combat. The vehicle is equipped with an uncrewed turret armed with a 50mm automatic cannon, along with sensors, communications equipment, and protection systems designed for an environment characterized by drones, precision strikes, modern anti-armor weapons, and electronic warfare. The approaching delivery is shown in a video published by American Rheinmetall on July 23, 2026, titled "A Key Milestone for the American Rheinmetall Lynx XM30." Program officials explain that the vehicles are moving from digital engineering to mobile physical prototypes assembled for use by soldiers. A text released by Team Lynx on August 4, 2026, provides additional context by arguing for a vehicle designed from the outset to replace the Bradley rather than an adaptation of the armored multipurpose vehicle. The next stage is expected to place military users inside the prototypes and push the vehicles to their limits. According to officials interviewed in the video, initial soldier activities are planned between September and October 2026, ahead of events associated with the National Training Center. This phase is intended to assess ergonomics, crew workload, visibility, dismount procedures, and access to components during maintenance. The vehicle is designed to operate with 2 crew members through the automation of several tasks previously distributed among 3 soldiers. Information from the sensors and fire control system is to be presented through a human-machine interface intended to reduce cognitive load. The 6 infantry personnel carried in the rear compartment are also expected to receive the vehicle's operational picture before dismounting, so they can identify nearby threats and act as soon as the rear ramp opens. Firepower is centered on a use-designed and manufactured uncrewed 50mm turret. The larger caliber is intended to provide greater range and effect than the 25mm M242 Bushmaster fitted to the M2 Bradley. It is meant to engage armored vehicles, fortified positions, and anti-armor teams at longer distances. The absence of a turret basket frees internal volume and keeps the crew within the main protected hull. The video also shows the integration of a 360-degree vision system that gives the driver a top-down view of the immediate surroundings. This feature was not part of the program's initial requirements. Rheinmetall states that it was added to reduce blind spots, improve maneuvering in confined areas, and lower the risk of accidents when dismounted soldiers are operating close to the hull. Protection combines modular armor with active and passive defensive measures. The internal arrangement separates personnel, ammunition, fuel, and other elements that could worsen the effects of a penetration. The Lynx XM30 is also expected to keep pace with M1 Abrams tanks across difficult terrain while supplying power to sensors, communications, electronic warfare systems, and counter-drone equipment. Its electrical, cooling, and computing reserves are intended to support the later integration of new software, sensors, and robotic systems. Replacing the M2 Bradley involves more than renewing an aging fleet. Since entering service in the early 1980s, the vehicle has become a central component of U.S. armored brigades by combining infantry transport, direct fire support, and anti-tank capability. Its use in Ukraine has shown the continued relevance of this combination in an environment saturated by artillery, drones, and mines. Ukrainian forces have used the Bradley to support localized assaults, evacuate soldiers under fire, and engage enemy vehicles with the TOW missile. The XM30 will therefore need to preserve the Bradley's ability to carry infantry into contact and continue fighting alongside them while overcoming limits in weight, electrical power, cooling, and electronic integration. Its 50mm cannon, uncrewed turret, and data-sharing systems are intended to support longer-range engagements, improve crew protection, and provide dismounted troops with a usable tactical picture before leaving the vehicle. The objective is not simply to produce a heavier Bradley, but to retain its battlefield utility while shortening the sequence from detection to decision and engagement. This development also reflects the operations the U.S. Army is preparing for across several theaters. In Europe, the XM30 would need to accompany Abrams tanks in high-intensity combat shaped by minefields, loitering munitions, precision fires, and disrupted communications. In the Indo-Pacific, its employment would likely be more concentrated, but no less demanding. Long distances, uneven infrastructure, and vulnerable supply lines would require heavy vehicles to be positioned around decisive locations, including ports, forward bases, transport corridors, and areas suitable for mechanized maneuver. In that context, the XM30's open architecture could support additional sensors, counter-drone systems, electronic warfare equipment, and the control of robotic platforms without requiring a major redesign. The program is intended to preserve the combat functions provided by the M2 Bradley while giving armored brigades a vehicle better suited to a more transparent, dispersed, and contested operational environment.